We are taking R.D. Sharma solution. We are taking chapter number 16, tangents and normals. And this is VSAQ. Very short answer questions. Find the point on the curve. This is the curve where the tangent is parallel to x-axis. So, if this is a Cartesian coordinate system, now this tangent which is parallel to, or any line which is parallel to x-axis, how do we find out the angle? The angle is the anti-clockwise direction from the positive x-axis, right? So that is what we call it as a slope or tan theta, or there are dy by dx, many names. So when the line is or the tangent is parallel to x-axis, the slope is 0. So let us differentiate this curve equation. We'll find dy by dx, and dy by dx is given in the question as 0. So let us find out the slope. I'm differentiating x square minus 2x. That will give us 2x minus 2, and that is equal to 0, because the slope is given as 0 because the tangent is parallel to x-axis, and as I explained, it is 0, so 2x equals to 2x is equal to 1. So we put it here. So y will be equal to 1 square minus 2 into 1. I'm just placing this x in the original equation in order to find out the y. Y will get 2. So this is 1 comma 2. Now this is the reference solution for you if you want to pursue it yourself. Find the slope of the tangent to the curve, this one and this one. Now this is the parametric form at t is equal to 2. So dy by dx we want first of all, because here we can get dx by dt. Here we can get dy by dt. In order to find out dy by dx, we have to divide them. So we'll put dx by dt in the denominator or dy by dt. And whatever value will come, we'll just put t equals to 2. So dx by dt will be what? It will be 2t. This is going to be plus 3. No problem here. Here dy by dx. So it will be 4t minus 2. Now just divide these two in order to get dy by dx. So when you divide these two, it's 2t plus 3. This is your dy by dx at t equals to 2. What will be dy by dx? Because this is slope only. So 4 into 2 minus 2 divided by 2 into 2 plus 3. So 4 to the 8, 8 minus 2 is 6 in the numerator. 2 to the 4, 4 plus 3 is 7. So what do you get? 6 by 7 as the slope of the tangent. So this is the reference solution for you. It's quite straightforward and easy question. I hope you'll be able to do by yourself. If the tangent line at a point P, x, y on the curve this is parallel to x-axis, then write the value of dy by dx. In the first question we have already discussed. See, if we want to find out this angle of this line or slope, we'll take it anti-clockwise from the positive x-axis. If a line is parallel to x-axis, that means it is almost equal to the x-axis. So angle with x-axis is 0. That is why dy by dx is 0. How are you going to write it? This is the whole content you have to put in on paper. Write the value of dy by dx if the normal to the curve y equals to fx at xy is parallel to y-axis. So they are not saying tangent first of all. They are not saying parallel to x-axis. First of all, it is normal, and normal is parallel to y-axis. So the tangent will be parallel to x-axis. Okay. Normal is this angle only. So this is 90 degree. So what is tan 90 degree? It's tan pi by 2 is infinite. So the normal slope is infinite. You have to find out the slope of the tangent, and slope of the tangent and normal multiplied, if you multiply them, you are going to get -1. That is, if you have a m1 which is normal, m2 which is tangent, multiply them, you will get it as -1. So tangent is equal to -1 by infinite. If you divide anything by infinite, it is going to be 0. So tangent slope will be 0. And simply saying, if line is perpendicular to or parallel to x-axis, it is perpendicular to a line which is parallel to y-axis, this is going to be the result. So let me show you how you are going to write. So this is the reference solution for you. If the tangent to the curve at point xy is equally inclined to the coordinate axis, then write the value of dy by dx. Now, so we have to find out the slope. Okay, I am making a line and you are very well aware of this line. So this is 45 degree from y-axis, 45 degree from x-axis. That means it is equally inclined to the coordinate axis. So you will be tempted to answer dy by dx tan 45 degree, because the slope is nothing but the angle from the x-axis taken in the anti-clockwise direction. What you will do? Tan theta you will find out, because it is 45 degree, tan 45 degree, it is going to be 1. You will answer it is 1. No, it's not 1. See, dy by dx, tan 45 degree or tan theta, all these are same. So this is going to be 1. But as I'm saying, if I make a line like this, this is also equally inclined to the coordinate axis. So there will be two lines, and if you make the anti-clockwise direction computation of the angle, the slope will be negative. Basically it's tan minus 45 degree, and you know tan minus theta is minus tan theta. So it will be minus 1. Plus minus both will be the answer. So this is the whole scenario which I just explained. This is how you're going to go about it. If the tangent line at a point xy on the curve y equals fx is parallel to y-axis, find the value of dy by dx. Now you have a Cartesian coordinate system. Tangent is parallel to x-axis. Not parallel to x-axis, sorry, y-axis. That is, the angle is, what is the angle? Pi by 2. And you know tan 90 degree is what? Infinite. Tan 90 degree is infinite. So what do you think the answer is? It has to be infinite. A tangent line which is parallel to y-axis, the angle from the anti-clockwise direction of x-axis is 90 degree. Tan 90 degree is what? Infinite. So the answer should be infinite. But I would like to show you one more angle to this, because in various solutions, various resources, I would like to put in front of you. See, so this is kind of solution they have given, but I would like to tell you that if it is parallel to y-axis, tangent, this angle is 90 degree, tan 90 degrees is infinite. So if you want to find out the normal slope, it will be 0, but it will be infinite in the case of whenever it is parallel to y-axis, because the angle is 90 degree. Find the slope of the normal at the point t on the curve x equals to 1 by t, y equals to t. So you just have to differentiate, find out dy by dx. When you find out dy by dx, just let me do the dx by dt. It is minus 1 by t square. Dy by dx, dy by dt will be 1, just divide them. So dx by dt will come here. So it will be 1 divided by minus 1 by t square. It will go up. But we don't have to do this, because see, the slope of normal has to be found out. So we have found out the slope of the, which one? Tangent. Normal and tangent, if you multiply the slopes, you're going to get -1. That means you have to find out not dy by dx, you have to find out -1 by dy by dx. So minus 1 by dy by dx. So we have minus 1 here. What is dy by dx? It is minus t square. So minus minus gets cancelled. You will get 1 by t square. And since there is no t, this will leave it with this. So the step-by-step discussion is this one. You have to follow this while writing. Write the coordinates of the point on the curve y equals to x, where the tangent line makes an angle pi by 4 with x-axis. Pi by 4 with x-axis means what? We have just seen a question like this. This is 45 degree. The line is equally inclined to x-axis and y-axis, coordinate x-axis. So tan 45 degree is what? It's going to be 1. So dy by dx is already given in the question. It is dy by dx, tan pi by 4 is 1. So when you differentiate this, 2y dy by dx equals to 1, dy by dx is equal to 1 by 2y. Okay, and that is equal to 1 because the slope is 1. We already found out tan 45 degree is equal to 1. So just equate it to 1. When you equate it to 1, 1 by 2y is equal to 1. So y is equal to what? Y is equal to half. Just put it in here so that you can find out x also. So when you put this y as half square, x will be equal to 1 by 4. So the coordinate points are x and y, that is 1 by 4 and 1 by 2. X comma y is what I have written here. Now let me show you, this is the whole scenario you have to follow step by step, and then you have to give the answer. Write the angle made by the tangent to the curve x equals e raised t cos t, y equals to e raised t sin t at t equals to pi by 4 with the x-axis. Now again, parametric form, dx by dt, dy by dt, you have to find out dy by dx, so just divide them too. But please remember sin pi by 4, cos pi by 4, that is cos sin 45 degree and cos 45 degree, they both amounts to 1 by root 2. That is what we are going to use just now. So let us take dx by dt. So I am using the product rule. So e raised t cos t will be minus sin t plus this is cos t, e raised t is e raised t. Now this dy by, now let us, because I am going to divide it directly. So let us find out dy by dt. Again I am using the product rule. E raised t cos t, then sin t will remain like that. Et will be et only. And dy by dx will be found out by dividing dx by dt, means putting it in the denominator. So I am just putting this negative et sin t plus cos t e raised t. Since et is everywhere, just cancel it out, or you can say divide every term by e raised t or numerator denominator by e raised t. So you will get cos t plus sin t divided by, I am writing it as, because it is negative sin t plus cos t, I am writing it as cos t minus sin t. Now what is t? T is pi by 4, and I already told you sin pi by 4 and cos pi by 4 is 1 by root 2. So why not to replace 1 by root 2 here? 1 by right root 2 plus 1 by root 2 divided by 1 by root 2 minus 1 by root 2. Since 1 by root 2 subtracted is 0, the answer will be infinite. That is, tan theta is infinite. And I have told you theta should be what? Pi by 2, because tan pi by 2 is infinite. So the angle is pi by 2, which is 90 degree. Alright. So this is dy by dx. This is nothing but the slope. Slope is infinite. That only comes when tan is pi by 2. Pi by 2 is the angle from the positive x-axis. Write the equation of the normal to the curve, this one. Y equals x plus sin x cos x at x equals to pi by 2. Now this is very straightforward question. Just differentiate. You already have a point x equals to pi by 2 if you want to find out the value of y, because you need the coordinates, and you have to find out the equation of not the tangent but the normal. So let me differentiate it first. So dy by dx is going to be equal to x will be 1, sin x cos x will use the product rule. So it will be sin x, cos x is minus sin x. We have done the cos x now, so let the cos x be it, and sin x is cos x. So you are getting sin square x and cos square x here, but with the negative. So it is 1 plus cos square x minus sin square x. Cos square x minus sin square x, this is your dy by dx. Now this is the slope of the tangent. At x equals to pi by 2, what will be the slope of the tangent? Just put x equals to pi by 2. So we have cos 0 as 1, cos pi by 2 is 0. Just remember this. Sin 0 is 0, sin pi by 2 is 1. So this is what you can remember. You can employ it here also. We have cos square x minus sin square x. So we have 1 plus cos square pi by 2 minus sin square pi by 2. So 1 plus, it is 0 square minus 1 square. So 1 minus 1 is going to be 0. So this dy by dx is 0. Now one more thing. See, x is equal to pi by 2. Because you want an equation for that, you need y also. If x is equal to pi by 2, you need a y also. So y is going to be equal to, I am putting x as pi by 2. It will be pi by 2 plus sin pi by 2 cos pi by 2. Now sin pi by 2 and cos pi by 2 are complementary. That means if one is 1, other is going to be 0 by default. So the one value will be 0 only if pi by 2 is left. So what are the x and y value? Pi by 2 and pi by 2. So we already have the dy by dx, but this is the dy by dx of the tangent. What will be the dy by dx or slope of the normal? When you have the tangent, just take the value of the tangent, divide and put it in the denominator with minus 1 in the numerator. That is what we have known up till now. Minus 1 by 0 it will be. So let us make the equation y minus y1 equals mx minus x1. So y minus and x1, y1 both are pi by 2. Both are pi by 2. M is what? Negative 1 by 0. Now normally we don't put it like that. It is infinite. But just for the sake of completion of this question, 0 multiplied. X minus pi by 2 is going to be equal to 0. The x is equal to pi by 2. You can write it as 2x equals to pi, or you can keep it as x equals to pi by 2. That is the equation of the normal. Now this is the reference solution for you. Whatever I have told you verbally, you have to write it. Find the coordinates of the point on the curve y square equals 3 minus 4x, where the tangent is parallel to the line, this one. So this is the line, and let us find out the slope first, and we have to find out the coordinates. Please remember, x and y we have to find out. So let us compare this with y equals to mx plus c, which is the standard equation. When you have a slope and an intercept, when we compare it with this m is going to be negative 2. M is negative 2. It's not 2, negative 2. I'll just change it. Now differentiate this one to y. dy by dx is going to be equal to 3 is going to be 0. It will be negative 4. So dy by dx, divide both sides by 2. Dy by dx is going to be equal to negative 2 divided by y. So this is the dy by dx, or the slope of the tangent. Now you already have the slope of the line which is parallel to this. So you can just equate this. Minus 2 equals minus 2 equals minus 2 by y. I have told you m is negative 2. So just put it as negative, make this one as positive. So you will get y is equal to plus 1. Now you have the value of y. Let us find out the value of x. Just put this y equals to 1 in the original equation. It's going to be this 3 minus 2. X is going to be equal to, this is 3 minus 1 actually. So x is 2 by 4, 1 by 2. So the coordinates which are being asked in the question, x is half, y is a 1. This is your answer. Now how to do this? This is the way you have to write. So this is the whole solution which you can follow and do it by yourself. Try it. You can do it by yourself, right? This is a very simple question. Write the equation of the tangent to the curve, this one, at the point where it crosses the y-axis. So let me show you this diagrammatically first, what they are asking. There is a line which is intersecting y-axis somewhere. We don't know the point as of now. Let us call it as, see, on y-axis x is equal to 0, and on x-axis y it is equal to 0. So at the point where it is intersecting the y-axis, the x has to be 0. Y can be any value, we will just find it out, but x has to be 0. So it will be 0 some y, right? Now this y will be what? Because x is already given. X is 0. So when you put x as 0, you'll get y. So 0 square minus 0 plus 2. This gives you y as 2. So the point of intersection of this line with the y-axis is 0, 2. So now we have the point. For the equation of the tangent, we need a point and the slope. So dy by dx is what? Just differentiate it, 2x minus 1, and you already have the value of x and y. X is 0, y is 2. Put it here, 2 into 0 minus 1. So that is negative 1. dy by dx is negative 1. Now formulate the equation. It is going to be y minus y1 equal to mx minus x1. That is what we are being doing up till now. And this is the standard equation. Negative 1 is the slope, 2, 0 and 2 and x and y. So the final equation will be x plus y minus 2 equals to 0. So this is the reference solution you can follow. As I said, this exercise have very similar and simple questions. Write the angle between the curves, these two curves at the point 1 and 2. See, there is no angle between curves. How can you find it out? The only way to find out the angle between curves is to make the tangent at the intersection point. So this angle between these two tangent is what? So this point of intersection 1, 2, we already have it. So you don't have to solve it. Or if you want to solve it, you are being provided 1, 2. So let us find out the m1 and m2 first, because we are interested in the angle between them. Tan theta, that is the angle between two lines, is given by the slope of two lines m1 and m2 considered. m1 minus m2 divided by 1 plus m1 m2. You just have to differentiate it. After differentiating, you already have the value as 1 and 2. And that is x and y. So differentiate it now. I'm differentiating the first equation. 2y divided by dx is going to be equal to 4. The second one is 2x equals 2 dy by dx. The first one will give you dy by dx as 2 to the 4. It's going to be 2 by y. The second one, dy by dx, is going to be equal to 2 gets cancelled. You have x, so you have 1, 2 as the point, which is already given in the question. Now just replace x and y by 1 and 2 in both of these dy by dx's. So you have 2 by 2, that is 1. This dy by dx, this is m2. So this is going to be x is 1. Now we have this m1 minus m2, 1 minus 1 divided by 1 plus m1 m2, that is 1 into 1. It doesn't matter because the numerator is going to be 0 anyways. So tan theta is 0. But at what angle theta, the tan theta is 0? It's 0. Tan 0 is 0. Sin 0 is 0. Cos 0 is 1. So theta is 0 is the answer. So this is the reference solution for you if you want to do it. And please remember, tan theta will always be under the absolute sign. Write the angle between the curves. So there are two curves at their point of intersections. So let us find out the point of intersection, find out the dy by dx, that is m1 and m2, and to find out the angle between them using the tan theta formula. At the point of intersection, so first we have to find out the intersection point. What will be the point of intersection? Let us solve it. Y is e raised minus x, y is e raised x. So I am just taking y equals e raised minus x from the first equation, putting it in the second equation. So y equals e raised minus x will be put in the second equation. E raised minus x will be equal to e raised x. You can write it as e raised x because e raised minus x is 1 by e raised x. This goes on the right, e raised 2x it will be, because the power are added if the base is same. So anything, see, 1 comes only when anything has the power of 0. Anything raised to 0 will always be 1. That has to be understood. So whatever you do, anything with raised to 0 is 1. So e raised 2x is 1. That means by the analogy and by the previous experience, we have 2x is equal to 0. Sorry, 2x is equal to 0, right? So when 2x is equal to 0, that definitely means 2 cannot be 0, 2 is 2. So x is 0. So x is 0 here. Now just put it in any of the equation when x is equal to 0. So if you put e raised 0, and as I said, anything to the raised 0 is a 1. So y is 1. X and y points are 0 and 1. These are the coordinate points for you, but the angle has to be found out. And first we have to differentiate these two. We'll call it as m1 dy by dx. The second one we'll call it as dy by dx again, and we'll call it as m2. So e raised minus x differentiation is e raised minus x, and differentiation of negative x is minus 1. Here it will be simple. There will be no negative, so e raised x is e raised x only. Now what the second thing is, m1 into m2 is what? Just multiply these two. Minus e raised minus x into e raised x. What do you get? You can write it as e raised x in the denominator. You can cancel this out. It is negative 1. So m1 into m2 is minus 1. So I'm just saying that the angle between them is 90 degree. When the angle is between two lines are 90 degree, we can say theta is equal to pi by 2. Theta is pi by 2. So that is the point of intersection. These are orthogonal. So this is the complete reference for you, so that you can do it by yourself later in the later discussions. Write the slope of the normal to the curve, this one, at the point 3 and 1 by 3. So please remember, it's normal, not tangent. So it's very straightforward. dy by dx can be computed 1 by x, as you know, it is already, we have done the differentiation minus 1 by x square. And this is the slope. This is the tangent slope. And what is the normal slope? It will be -1 divided by the slope of the tangent. That we already know. So it's going to go, this x square is going to go up. But what is x square? X is 3, y is 1 by 3. So 3 square is 9. So what will be the slope? It's 9. Don't have to do anything. This is the answer. So this is how you are going to solve it. You have to write everything, because I can give you solution in 10-20 seconds. But write the coordinates of the point at which the tangent to the curve, this one, is parallel to this line. So this is simply m. I can see it is 3. I have equated it with y equals to mx plus 3. M is going to be equal to 3. So the slope is known now. But we have to find out the coordinates. So dy by dx will find out. What will be dy by dx? It is 4x minus 1. Now this slope and this slope is equal. So equate this. 4x minus 1 equal to 3. 4x will be equal to 4. X is equal to 1. Now this x is equal to 1 is already known. We need to find out the coordinates. This x equals to 1 can be placed in this equation. So it will be 2 into 1 square minus 1 plus 1, that is going to be equal to 2 only. Y equals to 2. So what are the coordinates? X is 1, y is 2. That is the answer. Coordinates is asked. So this is the reference solution for you. You can just follow this. Write the equation of the normal to the curve y equals to cos x at 0, 1. First we'll find out the tangent, then we can go about the normal. Y is equal to cos x, dy by dx will be equal to cos x is minus sin x. Now what will be the value? Because 0 and 1 is already given, x and y is already given. This is the tangent, remember. So we have to find out the equation of the normal. The point is already given. What will be the normal? It will be -1 divided by minus sin x. It is going to be 1 by sin x. What is sin x? X is 0. X is 0. So 1 by sin 0. Sin 0. What is sin 0? Sin 0 is 0 only. 1 by 0 it will come. So this is very, not acceptable in mathematics, because we don't need 0 in the denominator. It is going to be infinite, undefined. But still, for the sake of completion, we have to do this. This is how it is done. We already have 1 by 0 as the normal, say, dy by dx of slope. But we already have a point. So in order to find out the equation of the normal, it will be y minus y1 equals to mx minus x1. M is going to be used as 1 by 0. Let us make it y minus 1. These are x and y. This is x equals to 0, y equals to 1 you are going to take. Y minus 1 will be equal to, this is 1 by 0. I am writing the slope. X minus x1, that is, what is x? It's 0. It's already given. So this is, just multiply this and, you can eliminate this. X minus 0 equals to 0. That just means x equals to 0. That is the equation. So this is how you are going to write, okay, everything. Write the equation of the tangent drawn to the curve y equals to sin x at the point x 0, 0. dy by dx, what is this? Sin x is cos x. The point is given x and y. So just put x as 0, cos 0 is 1, right? And the equation of the tangent, so simply y minus y1 equals to mx minus x1, both are 0, 0, so y minus 0 equals to m, x minus 0, m is what? We have already found out 1, so x minus 0, y equals x is the line of equation, x equals to y, you can call it. See, as I told you earlier that I can take 10 or 20 seconds to actually tell the logic, but you have to write it yourself, right? Okay, this is all about this discussion. Thank you so much and take care of yourself.